Hi, Assalamualaikum, a very good day I bid to everyone who's watching this video. I hope everyone is staying safe at home. My name is Anis Amira Amir and I'll be presenting on crude oil wax dissolution in Aqueous saline solution with the presence of Ionic liquids. So my presentation today will be divided into two major parts. The first part will be inclusive of introduction, problem statement, objective and literature review, and the second part will be covering methodology, result discussion as well as. But before we move further, let me explain to you on the overview of crude oil production and characterization. Gas, oil and water from a reservoir is extracted by a well to its surface facilities. The mixture of hydrocarbon will then be separated into its constituent phases before being transported by a pipeline transport to its onshore crude oil terminal. Crude oil in general can be categorized into four main fractions, which is saturates, aromatics, resins, and asphaltenes. Now, what is crude oil wax and how does it develop? Crude oil wax contains 40 to 60% of paraffin and is deposited when the temperature reaches wax appearance temperature. Say, for example, over here we have a crude oil pipeline with crude oil flowing into it. When the temperature reaches W80, crude oil wax will be deposited at the wall of the pipeline. And this is the real view of crude oil wax deposited in a pipeline. But why does this deposition matter? Crude oil wax will lead to the reduction in flow rate, which will also cause a production reduction. And not only that, it will also cause pipeline blockage, which can trigger safety issue as it can lead to high pressure. And in order to cater this, inductive heating, biological treatment, and pigging are being used as the current method for pipeline dewaxing. Pigging is widely used because of the feasibility of the process. Pipeline pigging is a pipeline mechanical cleaning method. This is the overview of a normal and successful pipeline pigging, which happens as the driving force of the pig is larger than the wax breaking force. However, because the crude oil wax contains 40 to 60% paraffin, the wax becomes harder and the driving force is no longer larger than the wax breaking force. This will reduce the pigging efficiency to 50% and will require more pigs for cleaning, cause severe damage to the pig and pipeline blockage. All of this will surely increase the operational expenditure. The current industrial solution to curb this problem is by injecting wax soaking solvent for at least 30 hours prior to pipeline pigging. The objective of doing this is to soften the hard wax before launching the pipeline pig inside the pipeline. And the major composition involved is benzene, toluene, and xylene. There are two major problems in the usage of the current wax soaking solvent. Firstly is the threats of the current main components. Benzene, toluene, and xylene are volatile organic compounds that lead to major effects to the health and environment. Health effects may start as simple as the irritation to the eyes and nose, but can also cause human cancer. Aquatic life, crops, and materials are also in danger because of these volatile organic compounds. The second problem rises on the complexity of transportation as well as high cost incurred. 20 to 30 drums of wax soaking solvent provided by a third-party vendor are needed per pigging process. These drums will then be shipped to the mother platform before the solvents are being used to soften the wax and ejected at the receiving terminal. This is definitely a very tedious process as the pigging occurrence frequency is depending on wax build-up curve. Hence, I can conclude my problem statement summary as follows. Firstly, we have the threats of current wax soaking solvent where we want to eliminate health and environmental threats. Next, we have the complexity of transportation issue where we want to solve the complexity issue as well as to have value savings opportunity. But by how? By dissolving the crude oil wax in aqueous saline solution in the presence of ionic liquid. This is by using saline-based solvent with ionic liquid using the readily available and abundant seawater. Thus, the objective of this project are as follows. First is to study the activity coefficient trend of different ionic liquid with saline solution as wax soaking solvent using a simulation software, and to optimize the performance of saline solution plus ionic liquids mixture as wax soaking solvent. And the objective can be achieved by using a simulation software called COSMO-RS, while the second objective can be achieved by varying temperatures as well as solvent to ionic liquid ratios. So ladies and gentlemen, what are ionic liquids? Ionic liquids are a combination of both a cation containing conjugated aromatic core and an anion which are strong hydrogen bond acceptors. Ionic liquids are popular among the researchers because of the unique characteristics such as low vapor pressure, high thermal and chemical stability, as well as low toxicity. In upstream industry, ionic liquid has the potential usage in enhanced oil recovery and can be used as wax and asphaltene inhibitors. To support, solubility of paraffin wax and heavy crude oil increased to about 60% with ionic liquids, and interfacial tension is reduced significantly with increasing ionic liquids concentrations. Now, let's review on the design of novel chemical solvent for waxy crude treatment without ionic liquid. In this paper, the solubility of crude oil in pure solvents was studied, and it was found out that carbon disulfide provides the highest solubility for crude oil in the solvent. However, carbon disulfide is not safe due to its incompatibilities, and carbon tetrachloride used virgin gas at high temperature and concentration, thus it is non-hygienic. The next study in this paper was on the solubility of crude oil in mixture of solvents. It was found out that mixture S12 has the highest solubility percentage, which consisting of 40% diesel, 25% xylene, and 25% toluene. Diesel is added to increase the flash point, while naphthalene is added to achieve better solubility of higher molecular weight hydrocarbon. Next, on the application of ionic liquids for heavy crude oil dissolution enhancement. In this paper, the solubility of heavy crude oil with wax soaking solvent plus ionic liquid is studied, and it is shown that the solubility of heavy crude oil increased by 60% with the presence of ionic liquid. The next study in this paper is on the interfacial tension of low waxy crude oil in ionic liquid plus sodium chloride, and it was found out that interfacial tension decreases with increasing sodium chloride concentration. In simulation part, a theoretical solvent screening with COSMO-RS was conducted. There were two simulation software involved. First is TurboMole X, which is used to stabilize and optimize the structural components of cations and anions using density functional theory. The second one is COSMO-RS, or conductor-like screening model for real solvent, which is used to study the thermodynamics properties of the combination of cation and anion. 10 cations and 5 anions are used for screening purpose. The cations are inclusive of various heat family type as well as various cation alkyl chain, and this is the list of anions involved. The anions and cations are screened against Aqueous structure or C20 structure to study the dissolution of crude oil wax. C20 is being used as the crude oil wax sample for experimental part is inclusive of C1 to C20 molecule. Hence, C20 is being selected to be modeled. Experimental methodology, solution and sample preparation. Firstly, 3 liters of saline solution were prepared at 40 ppt. This saline solution acts as seawater. Then, the crude oil wax sample received from ANSI platform of Petronas Carigali Sdn Bhd was molded into 0.05 gram small pieces. And 2 different solvent to ionic dilution were prepared by using 4 different ionic liquid solution, which adds up to a number of 8 different dilution. For phase 1, the molded crude oil waxes were then being put inside the vials containing different dilution of ionic liquids in saline solution and was left heated in an oil bath. This method is carried out for all 4 ionic liquids in 2 different ionic liquid to saline solution ratio at 2 different temperature, 70 degrees Celsius and 90 degrees Celsius for 3 hours. This method is repeated once for better result. After that, the solution inside the valve was extracted and transferred into another valve. The valve was then kept for UV-Vis purpose. For phase 2, the same method was repeated for BMIM-Cl plus ethyl acetate, and BMIM-Cl plus ethanol. The solvent to ionic liquid ratio used was 0.1 gram BMIM-Cl in 20 ml of saline. And for analysis part, there were two different analysis types carried out. First one was analytical analysis using UV-Vis, and the second one was data analysis using Microsoft Power BI. In this part, I'll be discussing on the results of simulation as well as experimental methodology. So first is simulation. From COSMO-RS calculations, a graph of activity coefficient of the ionic liquid is plotted. So this is the overall result, which consisting of a total 50 different cation and anions mixture. From the figure, it can be concluded that activity coefficient is determined by the nature of cation and anion of the ionic liquids. For example, the cation alkyl chain and the cation head family. However, the impact of anion seems to be more project than that of cation. Hence, a further study on the effects of anion nature on crude oil wax dissolution is carried out. So this is the graph of activity coefficient value for imidazolium-based ionic liquid with different anion. It was found out that BF4 has the lowest activity coefficient. Now, what does lowest activity coefficient means? In crude oil wax dissolution, a lower activity coefficient is favorable as it provides a better environment for the crude oil wax to dissolve. If we see the trend backward from fluoride, it can be deduced that it has increasing hydrophobicity that will lead to the rise in van der Waals energy. Next is the effects of cation nature on crude oil wax dissolution. First is cation head family. So, a graph of activity coefficient for C8 imidazolium, C8 pyridinium, and C8 pyrrolidinium is plotted. And it can be seen that pyridinium has the lowest activity coefficient, followed by imidazolium and pyrrolidinium. And the trend is the same as that of anion nature, because high nonpolar cation head family results in better dissolution of crude oil wax, as the crude oil wax is a nonpolar molecule. The summary of simulation findings can be found in this figure, where I have summarized the effects of anion and cation nature on crude oil wax dissolution according to COSMO-RS simulation. Moving on to experimental part. For experimental part, according to the analysis by using UV-Vis, the overall trend shows that BF4 has the highest absorbance value. And it was also proved that BF4 provides better dissolution than bromide and chloride anion. And imidazolium head family was also proved to has better effect than those of pyrrolidinium. Next is on the temperature effects. It is shown that higher temperature leads to better dissolution. This is because increase in temperature will lead to the rise in kinetic energy that will weaken the intermolecular hydrogen bonds. Last but not least, on the effects of the addition of other wax-soaking solvent, where ethanol and ethyl acetate was added to BMIM-Cl. It was found out that the solution with ethyl acetate improved the absorbance value by almost 50% than that of BMIM-Cl. As for conclusion, I would like to give the overall summary for my presentation. Firstly, I have emphasized on how peaking for pipeline dewaxing is crucial to avoid pipeline blockage. And because the wax is very hard, a wax-soaking solvent containing benzene, toluene, and xylene is used. However, the solvent leads to two major problems. Thus, this project proposed the replacement of the current wax-soaking solvent with saline solution, which is seawater, with ionic liquid. The first objective of this project is first to study the activity coefficient trend using simulation software, and second to optimize the performance of different ionic liquids with saline solution mixture. With simulation and experimental methodology that have been carried out, it was found out that higher hydrophobicity and non-polarity provides better environment for crude oil wax dissolution, and to optimize, higher temperature and concentration also leads to a better dissolution.